Welcome to the Chapter 9, Part 1 tutorial called Composition of Matter. In the Composition of Matter reading, it discusses pure substances and then it discusses mixtures. Substances are either elements or compounds, and elements are atoms that you find on the periodic table of the elements. So you might be familiar with some but not all of the different elements that make up the universe. Basically, atoms or elements are the building blocks that every piece of matter is made from. So it's one or more of these atoms that makes up every single thing that you see in the universe. We can actually combine atoms together and form compounds using what are called chemical bonds. Let me show you the difference between an element and a compound. So just as an example, here are some molecules of air that I'm representing. You've got oxygen, nitrogen, and carbon dioxide. Oxygen would be considered an element because it's made up of all one type of atom. There's two oxygen atoms. They're bonded to each other to form the oxygen molecule, which is why oxygen gas has the formula O2. The element oxygen is rarely found all by itself without a partner bonded to it. Same thing with nitrogen. Nitrogen atoms bond to each other, but O2 and N2, oxygen gas and nitrogen gas, are just two of the atoms that you find in the air, and those are elements. Carbon dioxide, however, contains two different types of atoms. It has a carbon atom in the middle and two oxygen atoms on the end. And actually, this is a terrible picture of carbon dioxide because it's really not crooked like that. It's actually straight. It looks like this. There's a carbon here and the oxygens are over here. But this is what happens when you take stuff off the internet. So carbon dioxide looks more like what I drew down on the bottom. And it has the formula CO2. This is what we call a compound. It has two or more atoms chemically bonded to each other. So that's kind of the definition of a compound. An element, by comparison, is all one type of atom. So let me put those definitions up for you. So I just added them up to the top for you. So an element is all one type of atom, and a compound is two or more atom types that are bonded to each other chemically. Both an element and a compound are considered pure substances. A pure substance is basically all one thing throughout. Now you might say to yourself, well, wait a minute, carbon dioxide doesn't seem like all one thing. It's got carbon and it has oxygen, and that's true, but because the carbon and oxygen are bonded to each other, the carbon atom and the oxygen atom lose themselves in the chemical bond. Instead of being carbon and oxygen, it's now carbon dioxide. It's all one thing because of that bonding. It's kind of like your iPad is all one thing, even though it's made up of lots of different moving parts and things. All those parts that are inside of it, if you take any one of them out, you really don't have a working iPad anymore. Same thing's true with the carbon dioxide. It's made up of individual pieces, but those pieces are not easy to take out, and if you do take them out, it won't be carbon dioxide anymore. Compare elements and compounds, which are pure substances, to mixtures. Here's a nice little graphic organizer that does that for you. You've got matter broken down into pure substances and mixtures. On the pure substances side with elements, you can see the difference between an element and a compound if you look at the pictures down here, right? Elements are all one type of atom. Compounds are a group of atoms bonded together like in water. But then mixtures have more than one type of element or compound mixed together. So for example, with wet sand, they're showing you water particles mixed with sand particles, and the sand particles are gray. And with this one, tea and sugar, they're showing you sugar particles, water particles, and tea particles all mixed together. So a mixture, not surprisingly, is a mix of several different pure substances. They could be elements or they could be compounds. The air around you is a mixture of a whole bunch of different elements and compounds. So there's two different kinds of mixtures, heterogeneous and homogeneous. Hetero refers to different. If something is hetero, it means it has differences in it. And if it's homo, it means it's the same. So a heterogeneous mixture is mixed in such a way that different parts of the mixture appear different to you, like sand and water. You usually have sand clumping up in one part and water clumping in the other part. A A homogeneous mixture, by comparison, looks the same throughout because it's very evenly mixed. This happens only with solutions, things that are able to dissolve. Because dissolving is something that happens particle to particle. Individual particles of your liquid are attracted to particles in your solid, and they actually pull it apart. You might remember from the 2 liquids lab that the Alka-Seltzer tablet dissolved in your water but not in your alcohol. And that's because Alka-Seltzer particles are attracted to water particles, but they're not attracted to alcohol particles, so it can't dissolve. When something does dissolve, though, you'll notice it dissolves evenly. When you make salt water or sugar water, the salt water or sugar water tastes the same throughout, and it has the same color throughout. And that's because the particles of the solid that dissolved get evenly spread out throughout it. And that's the homogeneous part. It's homo because it's the same. It's the same throughout. So that is section 9-1 in a nutshell. It talks a little bit more about solutions and things like that. There's a little section on something called a colloid and a suspension, and those things are important, but they're not emphasized in this course. So you can certainly have read about them if you wanted to read chapter 9-1, but they're not the key focus. So I'm going to do section 9-3 in a separate tutorial. See you there.